Welcome back, everyone, to day 4 of our completely free AWS Solution Architect Associate 2023 course. And this is to prepare you for the AWS Solution Architect certification. This is an AWS full course tutorial, and we provide free AWS certification training because I don't believe anybody should pay for certification training, ever. Certification is great to help you get an interview, but it's not the skills necessary to be a job. And I want it to be free for you to help build your brand so you can go out there and then learn the skills, not spend money on certification, and then build an elite technology career. This free AWS course is to prepare you for the SAA-C03 exam. And I've been having fun with you guys for the last couple of days. And we're here to finalize and finish the course today. So let me tell you about a few things before we get started. On Monday night, we have a completely free How to Get Your First Cloud Architect Job webinar, and it will tell you how to go from certified to hired. And believe me, there's a special skill there, and we're going to tell you. We specialize in it. We also have a completely free guide for you on how to get your first cloud architect job. Download that guide too. It's a free a free ebook that we wrote for you because I want you to get hired. And I retrain everybody else's AWS certified students. People have taken everybody else's boot camps, but they don't know architecture. They know every other skill other than architecture. We retrain them when we get you hired. So make sure you read that document. Make sure you come to the free webinar. And guess what? We've been aggressively going through the materials all week, which I've done intentionally. And what we're going to do is I want you to make sure to join us for extra hours on Zoom immediately after the YouTube streams. Register at the link. My team's going to pop the link in for you now. My guess is we'll finish around 2 hours today, and then we'll jump on Zoom for about an hour and 15 minutes. I've got a media interview at 4:30. The media comes to me constantly to ask about how to get people cloud architect jobs or the future of cloud, the future of networking, and all these things. It's almost a daily occurrence, but I don't have a media interview until 4:30. So until then, anything we can do to help you build your careers, and it's all going to be free from us. Now, a lot of you guys have worked hard this week, you've studied hard, and you made it to the final day. And I love rewarding people for making it to the final day. And since you made it to the final day, you can get early access to our Black Friday sale, which is 40% off. The link is in the chat box, and it will get you hired, and it will change your life. We're not big on discounts around here, but we're giving you early access to Black Friday. Don't lose this opportunity. We will almost never have pricing anything like this. And also, if you haven't subscribed, make sure you subscribe. Hit that bell to be notified, and let's go and build you an elite technology career. So yesterday, we were covering a bunch of AWS services, and guess what? Today, we're still going to be doing a bunch of AWS services. So we're going to start with Lambda. But before we do, give me a hashtag that says AWS SAA. Hashtag AWS SAA. Because I like to know that you're awake. I come from medicine. If you ever notice, we ask you, where are you? What time is it? Those kind of things. What day is it? Because we like to know that you're awake, alert, and oriented. So let me know that you're awake, alert, and oriented. And that way I know you're here, and then we will begin while I finish my really nice lemon balm tea. So to enjoy you guys in 1 minute. By the way, I recommend lemon balm tea. I mean, ask your doctor, obviously, but it's a very nice tea. And I found that I've been drinking it each day, and it's really good for my throat because I've got voiceover issues. And I highly recommend it. Makes a nice, happy tea. So anyway, I see you guys are here. I'm seeing all these AWS SAAs in the chat box. So let's start talking about Lambda. Now, one of the very interesting technologies and cloud computing is the ability to run these little mini functions, these little serverless functions. Now, you can run them in your data center with a private cloud. Nutanix has functions as a service, and OpenStack does as well. AWS has Lambda functions. Azure has Azure functions. Google has the equivalent. So what we're talking about is something you can do in any cloud provider. And I need you to know that, especially if it comes to actual work. You can't be like, I can only do this on AWS. Now, you can do it anywhere, including your data center. But it's really great. Here's the thing. Lambda runs on AWS's servers. They call it serverless, but that's just a marketing thing. It runs on servers. There's nothing out there that doesn't run on servers, but you don't have to think about the servers. So here's what it is. Basically, you upload a little bit of code, and it runs on somebody else's server, and you're unaware of where it's running. But, if you wanted to create something called an event-driven architecture where if this happens, then do this, this is where Lambda really shines. This is where Azure Functions shines. This is where any of these functions on a service in a private cloud, because sometimes you may want to remediate something. Maybe one of the people you have decided to pop an object in your object storage bucket or your S3, and they didn't list it right. They set it to public when it needs to be private. Well, the key is you can create an event-driven architecture, and Lambda can sense that mistake and go fix it for you without you thinking about it. So in my mind, Lambda functions, serverless functions are unbelievable. And pretty much you just upload your code and it goes. And they typically work with C#, Golang, Java, Node.js, Python. So you're really talking about pretty much everything. Let me give you an example of what it's going to look like in a picture. Sometimes that helps some people. You upload your load code to Lambda. You set up any kind of notifications. Whenever something happens, Lambda function runs, and then you pay for what you use. And that's the key. You pay every time this thing runs. So, as you think about this from an architecture perspective, I need you to understand, if it's running constantly, the bill on this is going to be so astronomically high. If it doesn't run, if it runs sporadically, this is going to be cost savings over setting up your servers and run the infrastructure. So it's like anything. If any of you know me and you know my architecture perspective, I don't love any technology. I love to make my clients successful. And I pick the right technology regardless what it is. I'm not married to any technology. I am married to making my customers successful. Architecture is supposed to be trusted advisors, not, I got a technology, I love it, you needed it here. You're like, I'm a hammer, let me nail it in. So keep that in the back of your mind. These serverless functions can get really expensive, really fast if they run constantly. And an example of constantly would be something like Amazon Prime. They put it all on these serverless functions, they ran it all like this, and it was 900% more expensive than it was to run it on a monolith. In fact, they went off of this microservice-based Lambda serverless type architecture because it was too expensive. But guess what? If it ran sporadically, it might be so much cheaper. So that's the key is, use it for the right things. But Lambda is incredible. Azure functions are great. Functions as a service are phenomenal, used in the right way. So as we talk about these functions, it's not like a big application. It's just like a little mini snippet of code. So by doing so, these functions are what's called stateless. Remember how we talked about the firewall keeping state of what went through it? And remembering, Lambda functions are stateless. So once they run, they're done, which means they don't remember anything. So if you want to have it step 1, step 2, step 3, step 4, step 5, you're going to need 5 separate Lambda functions, and that's okay. We're going to talk about how to schedule them too in a minute. These things are pretty cool, used in the right way. Lambda functions are highly useful in situations where automation can increase the efficiency and decrease manual intervention. So processing data across multiple systems, Lambda can do it. Remediation of a security event, like I told you, with an object storage bucket. When to patch your operating systems, Lambda functions are great. They can automate things. So if you think about those jobs, those entry-level jobs, and you start thinking of all these automation technologies we have, now you know why there's no entry-level jobs, why I get my people and my clients cloud architect jobs and solution architect jobs as their first job, because the more of this stuff that comes out there, the less need there is for sysadmins, the less needs there are for your entry-level people. So good, bad, depending upon where you're at. So Lambda can be, you typically run in response to an event. These are for event-driven architectures. So let's say we might have a user that could have a video processing application that optimizes the video and transcribes it. What do I mean by this? When I take out my 8K camera to run videos, I record it at 2200 megabit per second. So to put that into context, I can fill up a terabyte hard drive in a few minutes at the data rate that I actually record video. Now, nobody would be able to download that and watch that in real time at that unless they've got a 10 gigabit Ethernet internet connection. So What happens is we take video and we process it. We compress it with a codec. We do the same thing for voice over IP. And the point is, we've got to upload. A video company might upload their video. They might process the video, convert it to an H.264 MP4 codec. They might also get it transcribed, and they might want to do a couple of things in steps. And Lambda enables us to do these kind of things. Here's an example of a common Lambda type function you would use for someone in my world. What you would do is you'd upload your video. Where would you upload on the cloud a big video? Object storage. So you'd stick it in S3 if you're using AWS, or Blob if you're using Azure. On AWS, you'd set up an Azure a Lambda function. On Azure, you set up an Azure function. And that function can say, hey, take my raw video, send it to a video server, and convert it to compressed video. At the same time, I could have the video transcribed with Amazon Transcribe or any other AI transcription software. And then I could even have a message that says, hey, Mike, your video's ready. Here's the link to your video. And oh, by the way, here's your transcription as well. And I can set that up from just upload. And then I wouldn't have my team have to do that. So these Lambda functions are really great when they're used for the right reasons. That's the thing with any architecture, is picking the right technology for the right problem after evaluating all architectural trade-offs. So Lambda functions are in AWS's magical data centers, run on their servers. Now, what if you wanted to do something simple, where the second they hit your website, before it even gets to you, you run a Lambda function? So you can do that too. So let's say you're using, we talked about CloudFront yesterday. You've got your web servers hosted in your VPC. You're leveraging the CloudFront content delivery network, hopefully multiple content delivery networks like Amazon does. And as soon as that message hits your CloudFront content delivery network, you can run a Lambda function on it. And this is going to be called Lambda at Edge. And why? Because it's at the edge of your network, at the edge of the system. And it's going to let the Lambda function run closer to the user, which will enhance their performance. So, how would we set up Lambda at Edge? It's pretty simple. You upload your code. Your code's going to trigger Amazon CloudFront, and then the Lambda code will run every time it's invoked, and then you pay for it every time it runs. So that's the way that works. So I told you, what if you wanted to run multiple Lambda functions? I told you they weren't stateless. So if you wanted to do one, then two, then three, you got to tell it how to do it. And it's stateless, so we're going to have to get smart about it. So good news, AWS, they made a feature called Step Functions. So if you want to know what AWS Step Functions are, they're to schedule your Lambda functions. So we'll go through those. Step functions enable you to sequence functions, function 1, function 2, function 3, if you will. And of course, step functions are serverless, meaning they still run on a server, so don't fall into the marketing nonsense, but you don't have to maintain the server, so they call them serverless. What a great marketing term. The thing that runs on a server, but you don't have to think about it, so it's serverless. And what'll happen is you can schedule them step 1, 2, 3, 4. For example, we could put a file in S3. A Lambda function can send that to a virtual machine or EC2 instance for processing. Then when the processing is done, a Lambda function can send a message to DynamoDB and stick it in there. So that's why we're using step functions, to schedule function 1, function 2, function 3, function 4, function 5. So how does it work? We define the steps for the application in step functions. We then create our individual Lambda functions. So we've defined step 1, step 2, step 3. Then they upload the code per function. Then we configure the workflow in the steps. Then we connect all the workflow components to the individual tasks. And then we execute the step functions in normal use. So create the functions, tell them where you want to go and how to use them. And then the next step is to optimize after the fact. When you find out your functions don't work, when you find your functions are costing you too much money, those kinds of things. So step functions, step 1, step 2, step 3, step 4. These are the kind of things that you need to. So kind of keep these in the back of your mind. Now Now we're talking about another service, and we're going to talk about Amazon Inspector. And Amazon Inspector is an automated security assessment service that helps improve security and compliance. Basically, it's going to look at your applications for exposure, vulnerabilities, and deviations from best practice. I don't know if you've ever used any security tool and you notice that you get 18 million responses that are wrong. Some of them matter, some of them don't. And then you need people to mine through all these alerts and say, yes, it's supposed to be this way. Yes, it's supposed to be this way. And I got a lot of these things. For example, one time I put an IP address in an object storage bucket in the Google Cloud. 192.168.something.something. Well, I had one extra step, one extra space. So the Google automated alert sent me, you're exposing privileged medical data, because an IP address looked like an ICD-10 code, which is a medical diagnosis code. There was no medical data there, but the Google AI wasn't smart enough, so it sends us ridiculous alerts. All the providers send you ridiculous alerts. So I understand when you get these, some are going to be valuable, some you're going to have to disregard. So it's up to the knowledge of your security team to know whether they care about them or not. So Amazon will basically perform an inspection, and it will give you a list of what its security findings are by severity. And then you can check on them and figure out what you want to do about them or not do about them. Sorry, I had to sneeze. I'm highly allergic to cats, but I love a cat, and one sleeps literally over here on me every single night. So it is what it is. So now let's talk about the certificate manager. When you've got a website and you want some encryption, you need basically to put an SSL-based certificate. And where do you get the certificate from? A certificate authority, as a rule. And thank you, Dragonfly. So Amazon also has their own version of a certificate manager. And basically, it's a system that will manage your SSL and TLS certificates. And it's the AWS managed one. Certificate manager will, like any certificate server, will basically help add protection to your websites by using certificates to establish safe and secure connections. Certificate manager will enable simple provisioning and management and deployment of certificates, whether they be public certificates or private certificates. We'll talk about the difference in a minute. Certificate manager allows users to deploy certificates on AWS resources quickly and effectively. And certificate manager will provide free public certificates through your services like your load balancers and API gateways, which can front end your systems. So picture-wise, it's going to look like this. Your user goes to their certificate manager and they get a SSL certificate that you could put on your content delivery network, or you can put it on your load balancer. So we've got really two options when deploying certificates from the certificate manager. And we're going to talk about what those are. When you use these certificates, they're going to be deployed on your load balancers, your content delivery network, your API gateways for security. We have the private certificate authority. And this is for communication inside of an organization. So not the internet, the intranet. So keep that in the back of your mind. So with the private CA, you can get a certificate for users, computers, applications, services, and servers, and any kind of device inside of your systems. Private certificates are used in the internet and cannot be used in the public internet. Now, for private certificates, you got to pay for them with AWS. Public certificates are free. I don't know if we mentioned GuardDuty yesterday. It's another AWS service, and it helps monitor your AWS accounts. GuardDuty will analyze CloudTrail, DNS, VPC flow logs. It's going to look for patterns of behavior associated with compromised systems. It'll send you a CloudWatch event. So in security, we want to correlate events and look for things, and GuardDuty can do it. But mind you, there are industrial packages for security event management that are done, that run on all clouds, that are built by companies that do nothing other than security event management, not an add-on to cloud provider. So, there's options here. AWS is a good option. Just keeping this in the back of your mind. Macy's another security service that is fully managed. Basically, it gives you an inventory of your object storage buckets, a list of unencrypted buckets, publicly accessible buckets, buckets that are shared in and out of your organizations. And then it applies a machine learning technique and a pattern matching technique to give you information of things that you could be sensitive data that might be public and mistakes that you make. Now, you may notice there's a whole lot of services doing the same thing. What happens in a cloud provider or any tech company is the customer says, I need this or I won't buy. And then the cloud provider or the tech company will produce a feature just for that customer. And then poof, press release, brand new features. And they might be the same thing as something else, but a little different. And now it's a brand new feature. So let's talk about Kendra. Kendra is a fully managed search service by machine learning. Kendra lets the users look at structured and unstructured data. So think about databases and those kinds of things. It uses natural language processing to help understand the context of your query and find related answers. And then Kendra will index your documents, whether it's unstructured text like HTML, PowerPoint presentations, Word documents, plain text. And Kendra can also index your information like your frequently asked questions. Now, Kendra will look for attributes and documents and filter them. Custom attributes can be added to your documents as well as very specific searches. And of course, queries of information can be weighted towards more relevant results by increasing or decreasing the importance of the fields in your search. And we can do that with Kendra. The next service I'm going to talk to is Kinesis, which is used for streaming data. Kinesis is an exceptionally good service. It's exceptional, but it's AWS proprietary. If you've got streaming data like clickstream data or website clicks or information flowing in and you're multi-cloud, you may not want to use Amazon Kinesis. This is, again, not something good for multi-cloud. You can swap it out with Apache Kafka. It's what most organizations use in the world because it works across all data centers, all clouds, and a lot of workloads are still in data centers, and they run on Apache Kafka. But if you want a fully managed service, you don't want to set up your virtual machines, you're only going to be in the AWS cloud, you don't need high availability of multiple clouds, you're not going to be using systems across clouds, then you can use Kinesis. And Kinesis is a service for collecting, processing, and analyzing streaming data. Kinesis can collect and analyze streaming data in real time, and Kinesis can collect data from real-time applications, including video, audio, application logs, website click streams, and IoT devices. And unlike normal environments where you collect, store, and analyze the data, anytime you use one of these streaming data functions, you can kind of look at them in real time. So kind of keep this in the back of my mind. And unlike traditional environments where you collect, store, and analyze the data, Kinesis will do it in real time. So we do like it. Why would we use Kinesis? When we've got large amounts of streaming data and we want to look at it and do something with it. So think about weather sensors, these little IoT devices that are all over the world that every 5 minutes go, my temperature, my humidity, my humidity. We can look at this information and go, looks like a hurricane's coming, or looks like a storm's coming. So there's good uses for streaming data, lots of it. The quicker we can take information and make a business decision on it, the better the business will be. So understand, Kinesis, Kafka, these things are great. Now, this usually isn't covered on the associate. It's usually covered on the professional, but we're going to cover it anyway, just in case. And if it's not on your associate exam, who cares? You'll have the knowledge, and that's better. And if it is on there, bonus, you win. So we'll talk about Kinesis video streams, Kinesis data streams, Kinesis Firehose, and Kinesis Data Analytics. When it comes to Kinesis, the first one we'll talk about is Kinesis Firehose. Kinesis Data Firehose is a managed service to load streaming data into data stores, data lakes, or analytic services. Realistically speaking, Kinesis Data Firehose can capture data in real time and put it into object storage, Amazon Redshift, or other services. It's fully managed and it auto scales. So there's nothing for you to think about. And you don't have to think about it. You're paying. If it runs very little, it's cheap. If it runs constantly, it's cheaper to put it on a server and do it yourself. Your mileage may vary. You need to know your patterns. So when we deal with throughput on Kinesis Firehose or anything Kinesis related, we're measuring throughput in terms of shards. and you pay based upon shards. And prior to use, you need to determine your capacity in terms of shards. And you can increase the capacity in terms of shards when you need more. With Kinesis Data Firehose, we can have 10 shards, or basically streams, per account. And if we got a lot of data and we need it, you need to go beyond 10, you call Amazon support, they'll unlock it and they'll give you more. We can set up a policy to auto-scale the number of shards based upon utilization. And Kinesis Data Firehose can be set up from the console. Setup is essentially setting up the sources and destinations for the data. So real easy stuff here. Streaming data will be captured by the Firehose, and it'll be sent to wherever you want to put it, typically object storage or S3, but and then you can analyze it with analytics tools. Analytics tools, Power BI, Amazon QuickSight, those kinds of things. There's plenty of good tools. What's it look like architecturally, visually? You've got your streams. You put your streams in Firehose. You put them in an object storage bucket, and poof, there's your analytics or data visualization tools. Or run machine learning on it or something like that. So let's talk about a few things. When we're dealing with Kinesis Firehose concepts, we have the Kinesis Data Firehose delivery system. The underlying entity is that what we're talking about. You can use the Kinesis Data Firehose by creating Kinesis Data Firehose delivery stream and then sending data to it. We also want to talk about records in case they show up on an exam. Record is a data of interest that your data producer sends to the Kinesis Firehose delivery system. And your data can be as much as 1 megabyte. When we're talking about Kinesis and any of these systems, we have a data producer. Hope that makes sense. Something that produces the data and sends the data in the data stream. A web server that might be sending logs to the data stream, what have you. We have buffer sizes that we have to deal with and internal buffers. So what happens, Kinesis data stream will buffer incoming stream data and to a certain size, and it'll hold it for a certain period of time before it's delivered to the destination. Buffer size will be in megabytes and buffer intervals will be in seconds. How much you're going to send, how often you're going to send it. That's really all we're talking about. Now let's talk about Kinesis video streams, right? We're streaming video right now. So every device such as smart cars, smartphones, security cameras, and all these things that are sending video can be used with Kinesis video streams. And Kinesis video streams will automatically scale up and scale down. The Kinesis application video streams is for video. So what's going to happen is videos will be obtained via Kinesis media streams, and they can be sent for media processing or machine learning applications. You may have a corporate organization that films things of their employees in their employees' homes. And then they might want to run a machine learning application to make sure there's nothing offensive. Something that could offend someone on their religion, for example. Someone that could find some drug paraphernalia in someone's home. Someone could find some bad photos in someone's home. You name it. If you start looking at people's homes in Zoom, you'd be surprised what you find. And if it's corporate and it's related to a multi-billion or $1 trillion company, now there's a lot of liability if things offend people. So companies would use Kinesis video streams and associated machine learning to make sure nothing could be found to be offensive to people. What's it look like? Very simple. You've got a video stream, a video stream, a video stream. You send the Kinesis video, and it can be therefore sent to media processing. And then you can obviously analyze those videos. Like we talked about with machine learning, Kinesis Data Streams is a highly scalable platform for real-time streaming data. It can capture real-time data and send it to an analytics application within 70 milliseconds. So that's pretty quick. Kinesis Data Stream can capture gigabytes per second. It's going to be necessary for video to keep gigabytes per second, sometimes gigabytes a second, like hundreds of gigabytes a second if you're dealing with really high fast video, like my 8K camera. And it can take it in from thousands of sources. So think about that. Be able to pull things, capture video, process the video, send it to applications to be doing these things. So there's a lot of reasons to be doing this in real time. Now let's talk about Kinesis data streams. Well, we just talked about video streams, which was related to video, right? So data streams is related to data. Basically what happens, Kinesis data streams is to capture data. Then the streaming data is sent for processing. And then after it's processed, the data can be sent to a business intelligence tool like Power BI, Amazon QuickSight, those kinds of tools. Here's what Kinesis data stream looks like. Data comes into Kinesis data stream, then goes through Kinesis all the way to your Power BI or your whatever tool you want to use. Let's talk about some Kinesis data stream concepts. Again, we've got a data producer who's sending the data. Now we've got a data consumer here. And that's, when we're dealing with distributed Kinesis applications, it's where we're going to take the shards and where they're going to be sent. Most data consumers are retrieving the data in the shard and enabling some kind of real-time analytics. So producer makes it and consumer uses it and does something with it. Again, when we talk about data stream, we're talking about measurements, and all this stuff is in shards. The data stream will retain data for upwards of 24 hours by default, actually 24 hours by default, and you can make it up to 365 days, which is a year. Let's talk about when you would use Kinesis data streams. Large event data collection, real-time data analytics, for example, capturing gaming data, capturing mobile data, that sort of thing. So when we talk about Kinesis Data Analytics, it's a managed service to transform and analyze streaming data in real time. Kinesis Data Analytics will use and built-in Apache Flink to process data streams. Kinesis data streams are auto-scaling and will scale with the needs of the organization. And because they're functioning in a database-like manner, you can query them or look for information with standard SQL queries. With data analytics, we can capture the data and put it into Kinesis data streams, Firehose, Elasticsearch, S3, DynamoDB, or other data places. And Kinesis Data Analytics, we can capture the data from all these environments with Kinesis Data Analytics, and then Kinesis Data Analytics will analyze the data in real time. So think of a database, an object storage bucket, and something else goes into Kinesis Analytics, and you're analyzing it right then and there in real time, which will hopefully help your organization make better business decisions in real time. And the better business decisions they make, the better the organization does. Now, I had mentioned if you want something really good and really scalable across clouds and the ability to use standards-based tools, you use Apache Kafka. And Apache Kafka is very simple to set it up. You pop it on a virtual machine and you run it. Virtual machine on multi-clouds. But if you didn't want to manage it, there's a managed streaming service for Kafka with AWS as well. But again, I want you to understand this. Unmanaged, meaning you set it up yourself, means you maintain it, and you have 100% control over the performance of it, the customization of it. It is yours. Kind of like having my mother-in-law who was trained in Greece on how to cook Greek food. It's the best there is, but she knows how to do it, and it's not fast. Likewise, a managed service is like the local Greek restaurant to me. I walk in there and they have gyros and souvlakis ready. You push a button, you go in there and it's there. Now, is it what my mother-in-law cooks? Not even close. But it's quick, it's easy, and I don't have to ask my mother-in-law to spend 3 hours cooking. So, you have to choose the right one for you. But managed streaming for Apache Kafka is a fully managed service that enables you to build and run applications that use Kafka without thinking about the underlying infrastructure. So it's going to be fast and scalable and theoretically fault tolerant for you. And it's going to give you a unified high throughput distributed messaging system, relatively low latency for handling real-time feeds. It's also distributed, partitioned, and it can work with you. It's going to provide a publisher subscriber message bus that can be used and built in real time. It's Apache Kafka, other than somebody else manages the server for you. Apache Kafka, whether we're using it as a queue or whether we're using it as a message bus, basically enables that decoupling of systems. This is why you can use it to replace SQS. You can use it to replace Kinesis. Fantastic Apache Kafka. I mean, a really incredible big data tool. And basically what happens, you decouple your source systems and you put Apache Kafka in between. Kafka will provide a high throughput, low latency, fault tolerant message service that can process millions of messages per second. I mean, it's really good. So Apache Kafka can scale with organizational needs. Apache Kafka is used everywhere that uses big data. Somebody asked me about Outpost. Outpost is a server that AWS ships to you. That's it. So they call it a physical appliance because If you call it an appliance and you want to charge twice as much as the server would be, it sounds cool. Doesn't appliance sound good? But it's a server. It's got a hypervisor. But the key is that when you use the AWS Outpost, it acts like a VPC in your VPC, but the VPC is running in your data center. So by not having it in the cloud and having their server in your data center, you're going to get much better performance, lower latency. Of course, you could go to Dell, HP, IBM, Lenovo, have a server built, pay basically half for it, and run it yourself. But then you won't be able to use the AWS Management Console. So you're going to have to configure it like you would any other server. Maybe VMware, maybe KVM, QEMU, Citrix Zen, Microsoft Hyper-V, some other hypervisor. So AWS can pop a server in your data center, and therefore you get good processing. You'll get good processing power. You have low latency, and you don't have to think about managing. And you don't have to think about managing if they manage it for you. So let's talk briefly about Amazon Comprehend. Amazon Comprehend is another machine learning natural processing service. Natural processing is basically language processing is an AI technology, a deep learning technology that gives computers the ability to interpret text to speech or speak, that kind of thing. Human language is going to be dissected into pieces, so the grammatical structure of the sentences and the meaning will be evaluated by machine learning. From there, if appropriate, natural language processing will extract the critical components from the data, and it can identify things like sentiment by the words. So if you want to analyze what a lot of people say, you could use machine learning for it, and this is a pre-made, ready-to-go product. Again, make your own, make it custom to your needs. Go to McDonald's or Burger King, order your Big Mac fries and a Coke, and it comes out as a Big Mac fries and a Coke. Consistent. So, do you need something custom, or can you leverage something that's pre-made and ready to go for you? It all depends on your business needs. Let's go to questions for a few minutes, Chris, and then we'll come back. I don't want to spend too much time on questions because I want to finish early. Invite you all to Zoom where we can have a real live discussion and have all kinds of fun. What's the industry standard name for Lambda? Functions. Functions as a service would be a more standard function. Great question. Is Lambda deployed in the VPC? It's actually inside of the VPC. So it's not really something that's going to be outside the VPC like S3 would use your endpoint to connect to it. It's a different connection. Mark. Hi, Mark. It's good to see you. Is there any relation to shards and database sharding? It's different. So with database sharding, it's similar, but it's just a terminology. It's just a measurement of throughput, Mark, in this case. Good question, Mark. Yeah, very briefly, I'm answering some questions on YouTube. Richard LePasca is hilarious with his comment. Yes, I don't eat McDonald's. I basically eat chicken, fish, vegetables, fruit, nuts. I'm kind of a cross between a rabbit and a bear with what I eat. So that's hilarious, Richard. And I know you know me. I follow the paleo diet. But I do get coffee from McDonald's every once in a while, and I do like it. So tonight, remember, as soon as this session is over, we're going to go straight over to Zoom. We can have face-to-face conversations. We can run it right. So I want you to join us there. Also, if you've just joined us and you didn't know, we're having a How to Get Your First Cloud Architect job session on Monday. Please join us. And we've also written a free ebook on how to get your first cloud architect job. What's used instead of Lambda and multi-cloud? Well, you could realistically speaking run Lambda in AWS and an Azure function there. So everybody has their own systems. And the good news about Lambda functions or Azure functions or functions as a service is you can upload the same code to basically to Lambda as you could to Azure. So it's just if you're using these auto remediation services, they're there. Let me get to Nazar's question. Nazar, can you go from AWS certs to a job with no experience? Nazar, anybody can get any job they want with no experience. Anyone. But certification is only a small percentage of the skills that you actually need. Come afterwards. If you want to be a cloud architect, download that completely free ebook that we have. Come to the free webinar on Monday and we'll tell you how. I've got students in AWS and in Azure, in Deloitte, Accenture, KPMG, Capgemini, everywhere. Big banks that never had a job in their life. And I've got people with starting salaries of $150,000 to $200,000 a year as their first job. But less than 5% of the skills are covered in certifications. The other skills have to be taught. So I don't know the job that you want, Nazar, because each job has a very different skills. A cloud architect and a cloud engineer shouldn't even be related. They're not even related. One designs, presents, and sells. One is an executive. One is a hands-on engineer that codes and configures. The skill set is different. It takes me time to train cloud engineers to make them architects. As much time as it takes to take somebody new and turn them into a cloud architect. But the key is, any of you can get any job with no experience. A pilot gets their first job with no experience. A physician gets their first job with no experience. And you can too. So don't let the experience thing there. But you have to have the right skills. So download the free guide. Come on Monday. We can easily get you hired. And for the person that's disappointed that our cost went up, we've got a 40% discount right now, which is the biggest one we're ever going to run. So take advantage of it while they're there. So I guess we'll get back to the concept, the questions. Are there any more, Chris, that I can see? Okay, let's get back to the content. We'll get on Zoom early and we're going to have all kinds of fun. And if you guys want more career questions, I can answer that on Zoom too. I'm happy to, so come tonight. So let's talk about Elastic Transcoder. So it's a service for converting video between formats. Because I might upload video raw uncompressed, and I might need that. I might want to use one format on an iPhone screen, a different format for an 8K TV, a different format for a desktop computer. And Elastic Transcoder is one of the ways we could do this. Of course, we could just have our video editors export the video from their video editing software and a couple different things too. But if we didn't want to do that, and we didn't want to have systems with big CPUs and big GPUs, which we need for video editing anyway, we could basically send it up there and it could export it for us. And this way we can have different video for it. And Elastic Transcoder can handle large volumes and complex transcriptions as well. And it's easy to use because it's got a pretty simple workflow and a predefined video format that can be selected for output devices. It's available in lots of different AWS regions, and users can transcode where the content is stored. Here's the thing: if your users don't have good computers, this is going to be a way to do it without buying your systems good computers. But you have a good computer, your video editors have good systems, they can do it on those systems. So it's about choosing the right thing. Let's talk about Poly. Poly is a cloud service that transforms text into lifelike speech. Dozens of voices are available in different countries and different languages to make it feel like it's sort of a person talking to you. Poly's text-to-speech technology uses AI to create natural-sounding human speech, mostly natural-sounding. Now, neural to text-to-speech is a service that improves quality even further with advanced speaking styles, and it can be used to help people read through a document at a faster pace or even narrate a book. It can be used. Some people find it much faster to read a book. Some people can listen to an audio book. It's whether you're a visual learner, auditory learner, those kind of things. Poly can return audio in real time in a stream, which is quite good. And this makes it ideal for call centers as it can be used for reactions and prompts during phone calls to deliver automated responses to real-time information. Poly could be used as an announcer for public transportation. So I'm sure if you're in England and you hear this, mind the gap on the tube, that's the kind of thing we're talking about. Or when you get in the train station, railway exit, ding, 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 like you'd hear on New Jersey Transit. It's that kind of thing. It's perfect for those kind of things where you want to automate it and have a person not do things. Let's talk about Amazon Rekognition. So Amazon Rekognition is going to be a way to analyze videos and images using machine learning. We can identify faces to see if people are happy, are miserable, that kind of thing, because we might want to get consumer sentiment. We can look for unwanted content. You know, I know a recruiter who recently told me he was interviewing someone and he sent him to a really great customer, and the client that was going to hire the person said the person had something called the bong in the background, and he couldn't hire them. Now, if that person ran Rekognition on their system, they would leave their drug paraphernalia hidden and they wouldn't have any problem. But, you know, these are the kind of things that companies are using Rekognition for. But if you've got a logo that you don't want to be there, or an image. So these are the reasons organizations use machine learning for these applications. Let's talk about Amazon Textract. Amazon Textract is another machine learning service that extracts text from handwriting and data from scanned documents. Amazon Textract works by reading and processing millions of documents using machine learning. And from there, after reading the documents, text extract will extract numbers, handwriting, and information from tables, images, that sort of thing. Using Amazon Textract makes it easy for companies or businesses that deal with a lot of documents to automate the process of collecting information. Think about it, a hospital, a law firm, they could be going through thousands and thousands and thousands of pages or something. You can scan stuff, make it a little easier to find information, those kind of things. It's typically useful when it comes to extract information like business data, applicants' names, mortgage dates, rates, those kind of things. Let's talk about Amazon Translate. Well, this one probably doesn't need a lot of introduction. I say hello, and it says Yassas on the other end of Greek, or something like that. So Translate will translate one language to another. This stuff's all over the place. And it will use artificial intelligence to translate one language to another in real time. People of different languages can communicate despite the barriers they support. And these are things out there. And yes, I see the comments in the chat box. You can't make it up. If you interview thousands and thousands of people, you're going to see things that are interesting. And that's why companies use these kind of big tools to make sure their people don't do goofy stuff. And that doesn't make them look bad. Translate will use neural networks that will identify and intelligently translate languages it supports. And this helps in covering, from one language audience to another. Basically, when it comes to messaging, when it comes to translation, we have an encoder. The encoder will read through the website text word by word, and it will process the meaning of it. And it's done via something called an attention mechanism. That's the way AWS describes it. And the decoder uses the semantic meaning. What are they really trying to say? And then it uses that for translation, because we can all say things in different words. Translate is a service that can automatically detect an input source of language and tell the user what languages by the aid of Amazon Comprehend. To enable multilingual support, user experience, you can do it by an application integration. Translate company-authored content, such as meeting minutes, technician reports, and knowledge and posts. We can do these kind of things. And if you're noticing a lot of these things start to sound a lot related, there's a reason for it. I need this feature for my business. Let me take the old thing, add one new thing, and change it. So a lot of these things are going to be very similar. Alexa for business. Alexa is the stuff that listens to you constantly and sends data to Amazon. So there are businesses that choose to use Alexa, and they can put it in their conference rooms, for example. And it says, I have friends that are like, hey, Alexa, play me Bob Marley's No Woman, No Cry. That works, but I don't want anything listening to me, so I disable it in every system that I have. I'm security concerned. But, it's very cool for those of you that are looking to do things. It's also quite good for handicapped people. Do this for me. Text it. So you can think of Alexa that way. Alexa for Business enables IT to centrally manage and deploy Alexa services that would be used by employees, for example. It's commonly used in conference rooms, huddle spaces, phone booths, lobbies, and copy rooms. And any person in possession of a shared device that's on the Alexa system can use it. Now let's talk about Elastic Beanstalk. It is a service for provisioning, deploying, and scaling web applications and servers. Services, basically you upload your code and it deploys it for you. And theoretically, it's deployed with load balancers, auto scaling. So let's think about this. If we take CloudFormation, which is AWS proprietary, and we take Terraform, the DevOps engineer that configures it tells it exactly what we want. And it's precision. Elastic Beanstalk is you upload code and it just sort of does it all for you. The closer we get to fully automated, the more stuff that can go wrong, just from an experience perspective in technology. Elastic Beanstalk's a great service. If you're a web developer and you know nothing about networking and data center concepts, and you don't have a network engineer, and you don't have a network architect, and you don't have a data center architect, and you don't have a cloud architect, and you just want to upload code and have it run, Elastic Beanstalk is fantastic. So kind of think about that. Now, I also want you to think about this. Can a real business like a global bank not have networking people, not have security people, and not have really competent cloud people? No. Are they going to want to use something that's automatic, or are they going to want to use a precision for everything they need? They're not going to use automatic. But we got to look at each thing in each application and each service and say, when is it good and when is it not good? So I'm here to teach you what they are so you can pass the exam. I want you to develop the knowledge and the wisdom to know when to use what, when not to use what, and that's all on you. So you upload your code and it comes out and it is fully load balanced and it comes up with the tools. Basically, upload your code in Golang, Java, .NET, Node.js, PHP, Python, Ruby, and it will provision and manage the information. Of course, you'll get your logs via CloudWatch. Here's what the service actually looks like. You go to Beanstalk, poof, it auto deploys your stuff. Let's talk about Amplify. Amplify is going to be a service for the quick development and deployment of full stack web and mobile applications. Full stack applications are going to be made up of a front end, which is going to be the user interface, and a back end, which is where the servers do their work, the code, the databases, that sort of thing. And a developer can create an application without managing servers, including virtual machines, databases, so it's automatic for you. Amplify includes these main tools for development and hosting. Amplify Studio, which is a web browser-based visual development interface. It's going to allow for simplified drag and drop configuration of the application's front and back end. The Amplify CLI is going to be a command line that enables the development of the application's backend. The developer can choose from 175 AWS services to build and support their applications by just writing a few lines of code. Amplify Hosting is an update to push new and updated applications across the internet. Code is going to be retrieved from a GitHub repository or Amplify Studio interface, and it will deploy it. So there's going to be there's a trend towards low code and no code solutions. There's a trend towards trying to remove the technology professionals from possible, but it's usually going to be on the developer side, the back-end engineering side. See, what happens is architects bring in revenue to the organization because they design, present, and sell a solution. They don't touch it. And the people that build the solution cost a lot of money to the companies. So what they're trying to do is have more designers like me, more architects, and get rid of the engineers, use AI to do a lot of it, use low-code solutions to do of it, and that way, you can have all your front-end people that sell it, and on the back end, there's less expensive people to actually build it. So it's one of the reasons I say don't do engineering careers, do architecture careers in general. And there's a lot of other reasons which we can talk about tonight if you like. But I love engineers. They make everything possible. Without them, we've got nothing. So we've got to love them. We've got to respect them. But, you know, you also have to look at the macro and microeconomic factors out there, which are the people are trying to remove the back end and only keep the front end. So keep that in the back of your mind as you plan your career. Architecture careers can never be automated because of all the people and the relationship development and the sales and the executive presence. And we bring money to the company. So even during downturns, they need us. Back-end stuff can be automated. So start thinking about that as you plan on what you want to do. But the best people, regardless of whether engineers or architects, the best of the best are always going to be in demand. Let's talk about app discovery. So AWS Application Discovery is a service that helps enterprises migrate on-premise applications to the cloud. The service reveals data about business case creation and application migration planning, business case creation, a cost of operating in the cloud, the cost of migrating, the cost of leaving your infrastructure, the benefits of being in the cloud, and the cost of doing nothing. Well, yeah, on a tech by tech basis, but it doesn't evaluate the value of anything in the business. It doesn't talk about business optimization. So it's not going to be helpful to build a real business case. App discovery makes migration easier by allowing enterprises to make better business decisions around the specifics of each application. AWS application discovery collects server-like information like CPU disk and performance, and capture data can be sent and used. AWS application discovery used to collect detailed information about an enterprise's on-premise data center, and it uses this information in the most efficient manner. If you think you're an architect and you're going to convince a chief information officer, hey, I got this automated thing that built your business case, and get them to buy the solution, you're mistaken. Now, could this be a good tool for you to assess and see what they have and start look at planning and then start creating a business case? Yeah, it's a start. But for an architect, they're going to have some business acumen and business knowledge, and this is not going to be it. This can be used as a tool to support it. Kind of like when I did my MBA and they let you use a calculator to help you with the math. You had to know in your head what to do, but the calculator was there to make it easier on you to run some of the calculations. So those kind of things. Let's look at AWS AppFlow. It is a bidirectional service that moves and synchronizes data from third-party applications. It's a SaaS application, software as a service, like Salesforce, like SAP, which means you don't have to write any code. All that's going to be needed is to configure your data transfer, and AppFlow will take the rest of it. So you can take it from one application to another. By aggregating data from multiple sources, companies will be able to make observations, create hypotheses, and draw conclusions based upon the information that's consumed. And it will help organizations determine their amount that they need to pay for for a product and a service during its entire lifetime by helping people draw conclusions. AppFlow will improve the operational efficiency by collecting applications, services, processes, and devices to automate workflows. And the whole goal here is to reduce manual errors and theoretically reduce the cost of doing business. It's going to modernize data governance and clarity by moving of data between applications. Uses for AppFlow are to integrate applications quickly and easily, to transfer data to massive scale, and to automate data security. Now we talked about AppFlow, so let's talk about AppSync, which is going to be a simple solution that enables multiple applications to be connected and synchronized with data from multiple sources, including databases, Lambda functions, and OpenSearch. AppSync will automatically manage and update the data in web and mobile applications in real time. AppSync uses a publish or subscribe model to either push or pull data from multiple sources. And a template is going to be created to define where data is pulled from sources. I'll briefly discuss Cloud9. Cloud9 is going to be an integrated development environment, which is software that pulls together common tools that are used to build applications. Cloud9 will support 40+ programming languages and provides developers an environment with the tools necessary to build, run, and test. It'll offer users the ability to develop and deploy code and debug applications. This development environment is theoretically useful to help people save time as applications and will have the required tools that they need to, so we don't have to start configuring things separately. Cloud9 will also have some automated code generation and intelligent code completion features to cut down on the time that it actually takes to develop the code. Cloud9 will identify bugs in real time. It will highlight syntax, and developers do not have to switch between tools. CloudFormation is an infrastructure as code environment. In the world of multi-cloud, CloudFormation, in my mind, is ripe for the trash. Pick it up, throw it out, never touch it, never use it. Use Terraform instead. Have your users get trained and good on an application that's going to work on their Nutanix cloud, their OpenStack cloud, their Azure cloud, their AWS cloud, their Google cloud, their Alibaba cloud, their Dell cloud. Not like the learning a proprietary tool that's only good for AWS, but it's on the test. So CloudFormation is a way that you can template a system. You can deploy it quickly as infrastructure as code, just like the industry standard Terraform, which works everywhere. CloudFormation will make it easy for you to provision applications quickly. And it's basically a text file. So you can think of CloudFormation as a proprietary, only Amazon-based version of Terraform. So use Terraform. But I'm an architect. I don't use any of these tools, but the DevOps engineers and the cloud engineers will. Basically, you write your infrastructure as code. You pop it in your object storage, and then you launch it with a CloudFormation template, and it will launch your virtual machines, your containers, your storage, your everything as infrastructure and code. And infrastructure as code is great. CloudFormation templates are available for a variety of reasons. AWS has them. You can go to ChatGPT and ask it to write you a Terraform script or a CloudFormation script. It'll do it for you automatically, which is why I don't recommend those careers where you're doing these kinds of things. But it's there. They're not going to be perfect. You might need to tune them. CloudFormation templates are there. The code can be written from scratch, either using JSON or YAML format, just like you would use with a container environment. The code will be stored locally or in S3, and the code used by the CloudFormation, the console, the CLI, or the API. And then it'll provision your systems like any other infrastructure as code tool. CloudFormation will deploy your templates and your infrastructure. Now let's talk about code artifacts. AWS CodeArtifacts enables users to store packages during their application development. These software packages are stored in a repository like GitHub, so they can be accessed in the future for use. These packages can be simple files, log files, reports, logs. Why would a company use CodeArtifact? What's the point? Is to reduce delivery time by using code reuse. It's a fully managed service, so it takes the stress off of staff and management to limit the number of packages that can be stored. There's all kinds of code repositories out there that your DevOps engineers and your cloud engineers and your software engineers would probably use. Let's talk about CodeStar, which is a service that's going to assist with the creation, managing, and deployment of software applications. This service will facilitates a centralized console that can be used to assign projects to team members and the roles that are needed to do so. CodeStar will offer a single dashboard that will integrate software development tools, making it easier for developers and team members to collaborate. I didn't make up all these services. I'm just trying to prepare you for them for the exam. There's lots of these, and just keep that in the back of your mind. Now we'll talk about Data Exchange. AWS Data Exchange is a data subscription service that allows for the creation of data between organizations. Consumers can subscribe to various published data through the console. Data can be used for data-driven decisions using analytics and machine learning. Or on AWS Data Exchange, data providers can host various data sources such as payroll information, debit card transactions, healthcare, demographic information, what have you. If the data is provided as a data product, the customers can subscribe to it in AWS Data Exchange console or marketplace. Data in the data exchange can be organized in three ways, either as an asset, which is a piece of data, or revisions, which are a container for one or more assets, and data sets, which are a series of one or more revisions. Data Exchange also allows customers to migrate to the cloud with existing subscriptions. Device Farm, okay. AWS Device Farm allows developers to test their applications by using virtual devices available on the service without the need to buy physical devices like mobile phones for testing. These virtual devices cut across different platforms, including iOS, Android, and other web apps. AWS Device Farms allows testers and developers to test their applications. So maybe you've seen it. I'm sure anybody that's written code or applications know that there's virtual iPads, virtual iPhones, virtual Android devices. That's all this is. So that way you don't have to use a physical device. Of course, you can host it all on your own server too. There's other options for this, but this is one that you don't have to think about. It can be used for automated application testing. Users can upload and choose the application to test, select devices, operating system versions, and the number of devices to be used for test. Users can select as many virtual devices as they want, different variety of operating systems and states to get the outcome and see what it will look like in different environments. Forecast. Forecast is going to be a machine learning tool to assist with business forecasts. It works on time-based data analytics, analyzing older data first to the newest data to help businesses look through the past and try and make better forecasts or prediction. It's the whole reason we use machine learning. Hey, let's analyze the data in the past and let's figure out what we can do in the future. That's really all we're talking about here. Forecast, like any other artificial intelligence, data science tool, machine learning that's existed for the last 10 years, or actually 20 years or more, is really used for operational planning, because if you analyze the data, you can better predict your future needs. How about your supply chain? If you don't know what stuff you need and when you need it, and you've got a better supply chain with better information, you know which stuff to buy and when. It can be used by retailers. You're a store. Store wants to know how many to buy this many cashmere sweaters for the Christmas season, but doesn't want to leave too many. So resource planning, thinking about how many people I need for a project, how much of this I need. So that's why organizations use machine learning. Let's talk about Global Accelerator. Now, Global Accelerator is going to be an AWS managed service that optimizes global communication and data transfers between two devices. It provides an optimal pathway for the data exchange between an end user and the application. Global Accelerator will bring the applications closer to the user on the internet. And it uses health techs, and it'll create a couple of versions of this. And what'll happen is your internet routing will get you as close as possible. So, enhanced connectivity. Let's talk about Managed Grafana, and then we'll take a break and answer questions. For the most part, Managed Grafana is going to be a service to enhance productivity while making the use of Grafana applications by taking away one burden. Grafana is an open source analytics platform that can be used to visualize, query, and understand metrics. It's serverless and secure data visualization service. Managed Grafana is going to be a highly available, highly scalable. Again, there's regular Grafana too, removing the burden of upgrades and management. It'll provide a single dashboard for containing all resources and tools. It's highly interactive data visualization, and it will allow for easy communication with open source tools, AWS data sources, third-party tools, and other common cloud sources. And it supports the SAML, the Security Associated Markup Language, which is going to be used commonly with IAM, and it's highly secure and assures data protection. Okay, I think what we need to do is as follows. I think we need to open it up for some questions. I saw some pop up in there. Certificate manager, let's encrypt from. Okay, so here's when you would need a certificate. So let's say you want to go to www.gocloudcareers.com. I have the chance to send that to you, Tiku, in plain text, which the whole entire internet could see, or I could send it to you in a secure encrypted manner. So user to website is typically where you use a certificate. And that's going to assist with SSL-based encryption. Now, it's also quite possible to create an SSL VPN between a user and the remote access organization as well. We stopped doing that for the most part 20 years ago because IPsec was an improved version of doing this. And then during COVID, it was hard to find enough network engineers that were really good at deploying these things. So we went back to SSL VPNs to try and deploy things quickly. But it would typically use between a user and a web server. Now, we will have internal web servers, Tiku, which are inside of our organization. Maybe you're at your desk in the office and you want to update your social security number or your withholding taxes, and you want to go from your desktop to a server inside of you. That will be a private certificate that will be internet, as opposed to public, which would be you going to an external website. They're typically where you use certificate managers because you put the certificate on either the load balancer or the web server, and that terminates your encryption. I hope I answered your question, Tiku. If not, I can get much deeper into that right afterwards when we go on Zoom for a little while. With Terraform, does it relaunch everything as it was? So Terraform, whatever you deploy, it's going to do. No, Chris, I've seen lots of Terraform deployments. They are incredible, but I'm an architect, and architects don't touch the technology. So I've never actually done it, but I've watched other DevOps engineers deploy this in the future. So it's the configuration that's in that code. I don't know much more details than that because I'm an architect. But if you come tonight, chances are we've got a good DevOps engineer that I know that's probably going to join us on Zoom. And if you want to talk to him about that, we'd be happy immediately after this is over. Chris, we can go to the next one. Hi, Mike. Can I explain what is Fargate? Absolutely. So, bear with me 1 second. And what we're going to, this one I want to visually share with you. So, here's what Fargate is. So, let's say you wanted to run a container. When you run a container, you're going to need a control plane. And the control plane, which is typically going to be Kubernetes, and it should be Kubernetes. I wouldn't use anything else because this will work with everyone else. And so that's your Kubernetes container. And then you're going to have your containers over here. And here is what we're actually talking about. And so your containers have to exist on something. Now, if you want the ultimate control, what you will do is you'll create a virtual machine and you will pop your containers in the virtual machines. And you can put 20 to 100 containers on the virtual machine. When the CPU or the DRAM runs out on the virtual machine, you add another virtual machine, and it's a very simple, very effective. And if you're going to do this in your data center, you're going to do this. Quite frankly, if I'm going to run a multi-cloud environment, I'm going to have my Kubernetes control plane, and I'm going to put my containers on a virtual machine. Now, if I didn't, I don't know how I did that. If I didn't want to use a virtual machine, I could put my containers in a managed service called Fargate. And what happens is instead of maintaining my virtual machine, knowing my capacity, knowing what's going on, I stick them on what AWS considers servers. It runs on AWS servers, and I don't have to think about the virtual machine. That's called Fargate. So basically, it runs on AWS servers. You have no idea where it actually runs and the such. So, and then you pay when stuff runs. It's a different pricing model. Here's the thing. If you don't want to think about it, you put it on Fargate. If you want to control the performance of it, you put it on a virtual machine. So maybe this came across. The more you manage it yourself, the more control and precision you have. The more you outsource it to somebody else, the less you have. Which is why if you go to Morton's Steakhouse, for example, you can say, I would like this steak. I would like it butterflied. I would like some crab meat on top of it. I would like some asparagus on it, maybe some Oscar sauce. If you go to McDonald's, they say you got a burger, fries, and a Coke. So, think about it. Fargate is they manage it for you. Would you like your burgers, fries, and a Coke? Which keeps the maintenance off of you. It's very simple. It's very quick. The virtual machine gives you 100% complete control. Yeah, around that time, Chris. Let's go to the next one. With that being said, AWS Global Accelerator can be seen as a cross between Elasticache, edge computing. Not really. I would consider it to be like if you're going to upload your data somewhere, it leverages the network to give you an environment that's closer for you to upload it to. That's all it really is. So instead of making you go to the places farther away, it uses internet routing to get you a place a little closer. That's all I would consider Global Accelerator to become. What's the difference between Grafana and managed Grafana? Well, one you actually have full control and automation over. And one of them is AWS managed. So loss of control, loss of everything, but it's done by AWS for you. So one is an open standard. You manage it yourself on a virtual machine. One is basically it just runs and you don't have to think about it. What is Macy? Kingsley? Macy is an AWS proprietary tool that looks for things that are wrong. And if you were going to rely on AWS to do your security, you could do that. Now, Kingsley, there are companies that do nothing other than security that make some of the best and coolest security tools in the world that have been tried and true and tested by the biggest banks, etc. So here you want to get your security tool. That's all it is. It's an AWS security tool that's going to use some pattern matching. The AWS CloudFormation offers a variety of services. Can I highlight the most commonly used service for frequently encountered servers that cloud architects typically interact with? So Manoj, I want you to think about this. What problem are you trying to solve? So am I dealing with a food distributor that has to ship food across the world? Am I dealing with an airline that's working on something? Am I dealing with a global bank? Am I dealing with a credit card company? They all have different needs. So architecture is not about picking a bunch of AWS services and throwing it at it. It's about understanding what are these needs, all of the needs. What business problem does the organization solve? And then figure out which tools. Some will be AWS, some will not be. Sometimes you will need a tool. So I think we need to understand the architect thing a little more. So I'd love to invite you to come both after hours. We're going to start around 3 o'clock on Zoom. And I also want you to come to the Monday webinar. Again, it's going to be completely free. But problem first, what problem are you solving? It's no different than a physician. When I used to practice internal medicine, I might have had 1,000 different drugs that I used. And I needed all 1,000 drugs that were out there to potentially use. It was a matter of giving the right medication to the right medical conditions. So you've got to give me a business problem long before I can tell you which tools we want to use to solve them. Because each problem requires the use of different tools. But it's a great question. But I can tell you everywhere, you're going to use virtual machines. You're going to use Kubernetes everywhere. You'll use block storage, object storage, and file storage. There won't be an architecture used without a firewall. Hopefully they won't be managed by the cloud provider. There'll be a big next generation firewall. You'll use a content delivery network in pretty much every architecture you deal with. You will deal with load balancers in almost every architecture you deal with. And this applies across all clouds. That other stuff, then it's selecting exactly what you need for the job. Great questions. Okay, so let's talk about OpenSearch services. OpenSearch is going to be a tool that allows you to analyze and monitor large volumes of data from multiple sources. It will incorporate visualization tools that provide insights into unstructured and semi-structured data. In addition, it incorporates visualization tools to provide insights into unstructured and semi-structured data. When data is going to be captured and loaded into OpenSearch, it will use built-in services such as Grafana, full text querying, autocomplete, or scroll search to search, visualize, and give you data in real time. We can briefly mention Amazon Proton. Proton is an automated application delivery service focused primarily on containers and serverless workloads. Proton will enable platform teams to enforce controls and best practices on the underlying infrastructure. Proton will separate the infrastructure and code, effectively enabling collaboration between infrastructure teams. Proton will provide offerings in infrastructure as code, continuous integration, continuous delivery pipelines, and monitoring. And those templates can be replicated across environments. This deployment workflow is going to assist DevOps engineers with applications and setting them up. Now, this one's very cool. VMware on AWS Cloud. There's also VMware on Azure. There's VMware on everything. This is very cool. VMware Cloud on AWS is an infrastructure as a service solution that completes software-defined data center. VMware on Cloud VMware Cloud on AWS basically enables organizations to manage VMware servers. What does this mean? In your data center, you get a server, you smack a VMware hypervisor on it, it's got an interface to create your virtual machines. When you get VMware on the cloud, you basically get a dedicated host, a brand new server, and it runs VMware. Why is this so great? You don't even have to think about using any of the AWS stuff. It just runs in AWS the same way you did it in your data center. So now I've got VMware in my data center. I've got VMware in AWS, VMware in Azure. I don't have to train people on AWS anything. We can use all the cool VMware stuff we've always used and still use the AWS as a data center, which is really what it is. So kind of think about this. This is a phenomenal service. It enables customers to quickly and confidently scale up or down their capacity. They don't have to buy stuff. They can move stuff to the cloud when they need it, go back to their data center when they need it. And it's designed to run on dedicated bare metal services. Makes it very easy for data center migrations, a perfect disaster recovery environment, launch your system interesting, and it's there. So it's very cool. We can briefly touch Wavelength. Now, Wavelength is an infrastructure deployment model that's embedded for the telecommunications industry where they have 5G networks. This can be compared to a local zone, but it's designed for 5G. So it's going to be a low latency device. Why are we using edge computing? We might have these little sensors of airplanes and weather sensors, and we want to get them lower latency as possible. So wherever the 5G network is, we pop a data center, and that's called edge computing. We can briefly look at Amazon X-Ray, which is going to be a tool used to troubleshoot and identify root causes of performance issues. X-Ray looks at API requests as they travel through your application and produce a map. Developers can use X-Ray to analyze and debug their applications, and X-Ray will provide a full picture of the request passing through user services. X-Ray will work by collecting data from applications or services running in your system, and it will aggregate that data and combine the data to form traces of each application and services. Next, it will create a service map so you can visually look at what you've got going on, and that can be used to trace or debug or troubleshoot each service. Users can further drill down on each service to see the root cause. So organizations might use X-Ray for auditing purposes or trace requests to your applications to create a detailed service map of the applications you have, for finding bottlenecks in your systems to improve performance, to find and identify errors and bugs in your system. Now, containerization. I absolutely love containers, and people were asking me about Fargate and things like that. So let's talk about it. So here's a service to manage and orchestrate your containers. If you use it, you will have trouble. So I recommend using Kubernetes. This is a highly proprietary service which only works in AWS, and it's called the Elastic Container Service. So when you have containers, you need an orchestration, which could be this proprietary thing called ECS, or it could be a non-proprietary thing called Kubernetes, which works in every cloud, everywhere, all the time. The choice is yours. Lock yourself in, give yourself flexibility. One doesn't cost more than the other. It's an architectural option. A good architect doesn't design a solution that's only going to work now. They design a solution that's going to be there as the company needs it in the future. So if you use this, understand you're locking your people into AWS and they have no choice. So Elastic Container Service is a proprietary way to manage containers only on the AWS cloud. And what is a container? It's basically speaking an environment where you've got the application and its dependencies, and it uses a shared operating system. We use containers because they take less power than a virtual machine. And containers can often run, they're low weight, and they don't use a lot of resources. So let's look at this. Here's the way a container would run. And this doesn't matter whether it's Elastic Container Service. It doesn't matter whether it's Kubernetes. Pretty much it's the same thing. The containers are going to sit on a server or a virtual machine. We'll have the server. It'll have its operating system, and then we'll have container one. Container one could be MongoDB. Container two could be, anything. Container three, container four. So that is a container. Now, by comparison, you see how basically we have the server, the host operating system. The alternative to this is a virtual machine. And I love virtual machines, and I also love containers. But, it's probably worth you guys seeing the difference. So let's draw it out. The way a virtual machine would work is you would have the server. Then what you would have is you'd have what's called a hypervisor. And the hypervisor basically is a light application and that will manage the memory and CPU resources across devices. And then we'll create our virtual machines. And what will a virtual machine have? It will have the operating system. On top of the operating system, it will hold any dependencies that the application needs. And on top of the dependencies, it'll have the application itself. So I want you to think about this. We've got a server. It's got 256 cores in it. We might need one core just to run Windows. And I didn't spell it pretty. But we might need one core to run Windows. So if we've got multiple virtual machines here, we're going to have multiple copies of the operating system. And by doing so, each operating system that we have takes a lot of memory and CPU and bandwidth. So you can see here, if we've got to run 50 different Windows versions on a server, managing Windows 50 different times is going to put a lot of load on that server. By comparison, if it's a container, and we just have the server, the operating system, typically a container runtime module in our containers, we can put a lot more stuff on the same server. So containers are everything. There's times to use virtual machines. There's times to use container, but that's really what we're talking about. So Amazon ECS, Elastic Container Service, is a fully managed way to manage your containers. Again, proprietary, locks you into AWS. 98% of clients are multi-cloud, so this is going to mess you up in 98% of the cases, but we've got to cover it. It'll be on the exam. It's highly available, or theoretically, if you consider 99.99% highly available, and it's going to be deployed in every VPC, which means you can basically use your group. So you've got to put your virtual machines on something, or your containers on something, and that'll either be virtual machines or Fargate. So with a virtual machine, you'd use this proprietary service to manage your containers. You'd build your containers. You'd create your virtual machines, which they list as EC2. You'll provision the virtual machines the way you need, and you put your containers on there, and then you pay for the virtual machine. That's the way it would work without Fargate. Fargate, by comparison, you basically set your system up. You don't create the virtual machine. You build your containers, and it runs in a serverless environment, which means you pay every time these things run, and you have absolutely no control over what it does because it's on someone's infrastructure. Truth be told, Fargate works incredibly well. It's great. And if you use Kubernetes to manage it, and you put your stuff on virtual machine or Fargate or virtual machines, you can use that Kubernetes cluster across all clouds, which in my mind is a whole lot better. So scalable, easy to use. And that's why people like it, is they don't really need to know much to use it. Well, next, I mentioned Kubernetes. Now, there's going to be two ways that you can do Kubernetes. Before we talk about the Elastic Kubernetes service, understand that Kubernetes was invented by Google, and it is a phenomenal container orchestration platform. I want you to understand the next. If I create my own Kubernetes cluster, and I've got a server running in AWS, Kubernetes servers running in Azure, and Kubernetes servers running in Google, and the Google Cloud goes down, who cares? We still have the AWS and Azure clouds up and running. Because we built our own Kubernetes service. Now, if we use the AWS Elastic Kubernetes service, it is industry standard. We don't have to manage it. It manages itself for us, which is beautiful. So the Elastic Kubernetes service is a completely managed Kubernetes service. But if 50% of your containers are in AWS and 50% of your containers are in Azure, and we use the Elastic Container Service, which is hosted on the AWS Cloud, and the AWS Cloud goes down, we just lost all of our containers on Azure. And I don't think that's a good idea. So what's the workaround? Don't use Elastic Kubernetes Service. Build your own Kubernetes cluster. It's simple anyway. And stick it on every cloud you have. Done. And now you can have a cloud fail. Who cares? Your business is up or operational, and you don't get fired when the cloud goes down. But, that's me. But if you want to cheat If you want a simple, easily managed things, every cloud provider has a managed Kubernetes service, the Azure Kubernetes service, the AWS Elastic Kubernetes service. Google has a managed Kubernetes service, so anything McDonald's versus the custom restaurant, but understand those architectural implications. Use this Elastic Kubernetes service, the AWS cloud goes down, so do all your other clouds. Create your own Kubernetes cluster, you're there, but it should be Kubernetes, whichever one you use. And if you're single cloud now, and you want to start with the Elastic Kubernetes service, you can. And then if you need bigger and better, you create your own Kubernetes cluster, but everything's going to be the same because it's going to be Kubernetes. It's an industry standard. So no matter what, this is great. It is the industry standard version of ECS. So this is a much better option for you. And it's like anything else. It functions as your orchestration. And then after your orchestration, you store your information either on virtual machines or containers. You can see the Kubernetes service is managing the orchestration, and your containers here we've got either on Fargate or EC2, which is basically virtual machines. Done, simple, easy to go. So let's talk about the EKS distro. And this is going to be a service that lets users run containerized applications in their data center the same way you put them in AWS. It enables users to create Kubernetes clusters with the exact version of Kubernetes in the AWS. The main difference between EKS and EKS distro is EKS distro is fully managed on AWS, where EKS distro is available for you to download anywhere. So it's an alternative to you basically just going to Kubernetes and downloading and installing it yourself. EKS distro can be used for hybrid clusters. If you want to use Kubernetes clusters to span the data center in the cloud, this is perfect. It can also be used for disaster recovery, or build your own and run it on all clouds and stay away from anything that somebody else is managing for you. Choice is yours. Now let's talk about the Elastic Container Registry, which is going to be a product that stores and manages all of your container images and that are going to be managed by clusters of virtual machines. The Elastic Container Registry will allow all developers to save configurations and quickly migrate them into a production environment. The Container Registry will provide a command line interface and APIs to manage the repositories such as the Elastic Container Service as such. Elastic Container Registry is a secure, scalable, reliable service to access and distribute the application images faster. It's a place to store it. In fact, that's really what we're talking about. EKS Anywhere, and this is basically it's designed to help people simplify their on-premise Kubernetes cluster management with default configurations, provides auto scaling and self-healing. It offers a reliable and consistent Kubernetes cluster on premises, and they'll tell you it's better for them to manage it than for you to manage it. Choice is yours. Theoretically, it reduces support costs because there's less people and third parties to deal with. And it's open source software with optional support from AWS. When does AWS, and they make the test, recommend to use EKS Anywhere? It simplifies your management. So they recommend it when you're trying to do it in a simpler manner. That's really what they're talking about. Okay, so we're briefly going to talk about some IoT devices, Internet of Things. They've been popping up on the recent exams. Internet of Things are anything that has an IP address. Your refrigerator that can text you is an Internet of Things device. The sauna that I have in my home that can send me messages, and a dashboard that can show me my heart rate when I'm in the sauna, those kind of things, is an Internet of Things device. So weather sensors are Internet of Things devices. Airplanes sending beacons are Internet of Things devices. So there's a lot of Internet of Things devices out there. And when we're dealing with IoT devices, there are a tremendous number of great management platforms out there. And who has the most experience with Internet of Things devices? Well, networking people like Cisco and Juniper Networks. They've got lots of experience with Internet of Things because they've been making this stuff work now for 20 years. But AWS also has some Internet of Things. And we're going to begin with IoT Core. And that's going to be a cloud service that will act as a communications gateway, message broker, and device application internet interface for Internet Connected of Things devices. And in order to use Amazon's IoT devices or Internet of Things, this is pretty much a foundational solution for deploying, managing, analyzing, and maintaining your IoT devices. IoT Core provides scalable and AWS maintained solution that will supply secure connectivity to and from your devices. It's rule-based, and it will use the ILP data to get its information. IoT Core can reduce the operational burden for IoT devices by providing a platform that supports communication and management of an IoT architecture and infrastructure. The service is managed by AWS engineers, so you don't have to think about how it's running like anything else. The service facilitates communication between devices, cloud services, applications. It's got built-in authentication, authorization, and authorization of the devices. It has a REST API for being able to integrate to it. And it supports access control lists and other things to make sure we can secure the communication. Generally speaking, IoT services would be beneficial to a scenario where you need to connect a fleet of IoT devices like weather sensors to back-end AWS services. This access will give users the ability to process information real time, and the service can handle a device fleet ranging from a single device to billions of devices. And it's going to look like this. You can see you've got your devices. You've got your IoT Core services, and that will connect you to the other systems. It's really a management connectivity platform. So you got all these devices. How do you manage them? All the stuff out there. Well, the devices could have their own tools, or you could use an AWS tool called Device Management. And IoT Device Management is a device inventory and management service for Internet of Things devices. It will organize your AWS IoT devices, so you can usually register the device, its information, its configurations. You can organize where they're inventoried, and you can monitor them. So, management systems. IoT Device Management will help track, monitor, and manage your devices. You can look at it to provide health information on your devices, etc. It's great for remote fleet monitoring, to perform bulk updates of things like to firmware to your devices, for example, to create groupings of things so you can look at them, see what you've got, and deal with them, because you may have so many of these devices out there. So we talked about the core, which is the foundation. Then we talked about the management, how are you going to see what's out there? Now let's talk about IoT events. And as you would think, IoT Events is going to be a cloud-based service that's going to monitor data from applications and equipment. And if an event occurs, like something goes wrong, it can trigger a response. IoT Events run serverless, so you don't have to think about managing servers, patching operating systems if you have. IoT Events monitors ongoing data from IoT device sensors and applications to integrate with other services like IoT Core and AWS IoT Analytics. And it's going to give you insights so you can take actions. Now, IoT Events will monitor your equipment, and you can take these inputs from multiple sources, and you can also route sensor data to IoT Events. So, you want to see it. So, core foundation, management, how do you manage these things, events, what goes on, what can you do about it? Now we'll briefly discuss IoT Things Graph. Well, named pretty straightforward. IoT Things Graph is a service to enable non-developers, remember everything's going low code or no code, or AI code generated whenever possible, to visually create workflows between sensors and assets and web services. It can help people build quick Internet of Things applications by connecting devices and web services to different vendors that speak different protocols. It's a visual, there's a visual editor, so we can create a graph to see things, and you basically pay for what you use, but there's no minimum fees on this. Now, we talked about management, we talked about foundations, we looked about visualization. Now let's talk about analytics. IoT Analytics will basically take stored data and help get it to you. We can prepare data in an easily managed, easily processed format, easily analyzed. We can predict maintenance when we need to do maintenance to our IT fleet. and it's going to help build applications that monitor inventories in real time. So we've got to have some data about our fleet of devices out there, especially when there's thousands or hundreds of thousands out there. And again, it's going to be a fully managed service, so there's nothing to deal with. Okay, cost management. We're going to do the best we can. The simplest approach to cost management is to stay in the data center. But we're not, as architects, we're more concerned about optimizing the business than necessarily the cost. If I can help a business double their sales and they're at 10 billion and I can get them to 20 billion and the solution costs 3 billion, then guess what? If we can get a $10 billion in revenue for 3 billion in sales, assuming the organization's margins are good, this is woohoo, this is awesome. So kind of keep that in the back of your mind. So think of cloud computing as a business agility. Do this faster, do this faster, do this faster, and less about the cost. But cost does matter. So we're going to talk about cost. When we move to the cloud, it's going to have a substantial change in the organization's cost. In some scenarios, moving to the cloud will be cheaper. In other scenarios, the moving to the cloud will be much more expensive. But there will be a shift in expenses. When we buy it, it's a capital expenditure. We purchase it once. When we rent it, and cloud is rent, we become ongoing rents. Now, buying it might be cheaper, or renting it might be cheaper, depending upon how long we want to be using something. So keep that. But we shift the purchase from purchase to purchase the equipment to much higher rental fees. Because remember, a landlord needs to make money, which means they have to buy the infrastructure, run the infrastructure, sell the infrastructure, have a marketing machine, and have all the employees there. So kind of think about it. Now you know why the cloud's usually more expensive, but more agile, which is worth it for the business in most cases anyway. What do you pay for in the data center? Your servers, your routers, your switches, your firewalls, your load balancers, your racks, your power systems, transformers, generators, UPS systems, power distribution units, your cooling equipment, and of course the real estate. So large capital expenditures, moderate operational expenditures. Here's your operational expenditures: your staffing, your electric bills, and your networking connections. In the data center, most of the costs are one time for equipment. In cloud, you don't purchase a lot, but you pay very high prices for everything. So that's an operational expense. When you go to the cloud, there's operational expenses. So how do you reduce costs? You plan it. And you only use what you need. That helps. Step 1, provision what you need and no more. Step 2, perform capacity planning. I know a lot of people say with the cloud, it just auto scales. You don't need to know. If you don't need to know, you're going to pay a lot more than you need to. So figure out exactly what you need. Build it for what you need, average. And that's the advantage here. In the data center, we have to build for what it could be at peak utilization. In the cloud, we can build for average utilization. We can auto scale as necessary for peaks. Kind of keep that in the back of your mind. So that can be here. We decouple our systems whenever possible, and that will enable us to use smaller systems, which cost less. We use the right platform for our virtual machines. If we understand our environment, guess what? We can purchase it for 3 years out on a reserved instance and save money, like we talked about. If it's a batch job and it's not critical, we can use a spot instance, which is cheaper. If we don't know, we can use on demand until we figure it out, and then poof, we switch it over to reserved. The best cost we use a combination. If you don't use your systems a lot, use managed services and serverless. If you use your systems a lot, don't use serverless because you pay each time it's invoked. Step 5, think about your data transfer costs. If I buy a 10 gig connection between my house and Chris's house, which is, I pay, say, $5,000 a month for the connection. In the cloud, I pay $5,000 a month for the connection. I pay a daily fee for the connection, and then I pay to send data across the connection. So data transfer costs in the cloud can get big really fast. So manage your data transfer costs. Try to maybe keep the data from hitting your network. Use CloudFront when you can. It'll reduce your systems, use a content delivery network. If you've got an object storage bucket-based website, use some cross-regional replication so you're sending less data across the cloud. And we have to analyze our data. If we don't send a lot of data over the wide area network between our organization and the cloud, a VPN is usually cheaper. If we send a lot of data, the direct connection is cheaper, meaning you've got to know what you're using and how you're using it. Let's talk briefly about budgets. You know, in the data center, you know what your costs are. You buy it. You know what it is. Nothing changes. In the cloud, you pay what you use. So people get very surprised by their cloud bills. So what you can do is you can set what's up a budget. Let's say you set up a budget for $500,000 a month. We can set up an alert when you hit 250,000, set up another alert when you hit 495, and then you can figure out, do we go up or go down? $500,000 a month on the cloud is very minimal. For a real enterprise, it would be a lot more than that in most cases. But you set up a budget, you create your rules, and you'll get notified when you reach things. So pretty simple. Now, there's also a system you could use, Trusted Advisor. Trusted Advisor generally refers to an objective person that's not biased for anything. So AWS has a service called Trusted Advisor, where they tell you what to do to spend less money. Okay. Now, the stock price is determined by how much money you spend, but they're telling you how to spend less money, so think about it. It's an automated machine. Trusted Advisor is going to be an online platform that will help figure out what you're doing, and it's going to scan your infrastructure, and it's going to recommend AWS best practices. And there's going to be two versions of Trusted Advisor. There's going to be the basic and developer support plans, where customers will get access to 5 security checks and 50 service limit checks. And organizations on business support plans, or enterprise support plans, will receive 115 Trusted Advisor checks, of which 14 will be cost optimization, 17 will be security, 24 will be fault tolerance, 10 will be performance, and 50 will be service limits. Let's talk about Compute Optimizer, and that's going to be a free management tool that will recommend AWS resources and efficiencies to reduce costs. Cost Optimizer reviews previous resources and activity to distinguish use patterns. Compute Optimizer will compare the user's activities to similar activities. We can also talk about service quotas. Service quotas give the ability to view logs and set limits on several services that integrate with the AWS dashboard. They will help to scale various resources as workloads increase, and users can actually adjust service quotas and monitor them by setting up alerts to inform users on pending limits. This will keep users from unintentional spending increases that negatively impact the company's overhead. It's going to be an excellent resource because it allows users to look up logs and determine the needs for service increases in a perfect area before you need them. Forecast is going to be a machine learning tool to assist with, we actually talked about Forecast. I'm not sure how I got there. Okay. So we'll briefly address high availability architectures. Availability refers to the service being available when you need it. Designing for high availability can get pretty expensive pretty quick. We'll talk about the levels of availability: 99%, 99.9%, 99.99%, and 99.99%. Many organizations would consider 99.99% high available. That means 5 hours of downtime per year, unplanned downtime. Now, if you're a hospital, 5 hours of unplanned downtime means people die. If you're a bank, 5 hours of unplanned downtime could mean huge financial costs. So they typically need 99.99%. When you build a high availability system, it means no single points of failure. That means redundant connections to the clouds. It means the devices that are connected to the clouds probably need to be plugged into 2 power supplies. It means if you've got connections to the cloud, they need to be on different service providers. It really means you need to use multiple clouds. So what we're really talking about is no single points of failure anywhere. Now, I'm going to tell you what you need to for the exam, but if it really needs high availability, it needs to be multi-cloud or hybrid cloud. But for the exam, I'm going to give you what you need to know. So no single points of failure. That means redundant power, redundant cooling, redundant networking connections, redundant routers, switches, servers, load balancers, redundant DNS environments, redundant storage, redundant applications, redundancy everywhere. Now, theoretically, AWS maintains redundant power. A data center should never have a power failure, although AWS had a multi-power power outage due to a power failure. So we're going to assume they have redundant power and it just malfunctioned. We are going to assume they have redundant air conditioners in their data center, like you would when you design a data center, and you would use multiple power companies if you designed a data center properly. We are going to assume they've got redundant internet connections and redundant networking connections across their backbone, redundant routers, redundant switches. And the reality is, for most people, it will be much easier to design for high availability on the cloud than in the data center, because they're not going to know how. You really need those CCI level people and above, and that's intro level for designing high availability people, CCI, just intro level. You're going to need those kind of people to be able to design for high availability. So multi-availability zone, each availability zone is a data center. The AWS will tell you can get to 99.99% available if you use 2 availability zones. We're going to work with that. Very few of the cloud providers have delivered 99.99% available in the last few years, no matter what people have done. But for your exam, 2 availability zones, 99.99% available. Now, for your exam, if you need greater than that, you're going to have to use 2 availability zones in 2 regions. Now, in reality, your regions are connected via BGP. They're sharing network information. They're sharing a control plane. One region goes down, the whole cloud can go down. But for your exam, 2 availability zones, 99.99. 2 availability zones in 2 regions gives you 99.999% of the time, assuming you've got the right change control and everything else. And you're going to need high availability. I can't really discuss high availability in 3 minutes. It's a 50-hour to 150-hour discussion for designing for high availability. Students in our cloud architecture development program do a lot of this. But it's going to be redundancy in your connections, redundancy everywhere. Now let's talk about high availability. Let's talk security. If your systems aren't secure, they will be hacked and your systems will go down. So let's think about that. Make sure you're using the best next generation firewalls in your architectures. Use the principle of least privilege. Have your security architects lock down your servers and reduce unnecessary services. Patch your systems. Limit blast radius by basically speaking, limit either using AWS organizations or drop your system into 30 or 50 or 100 VPCs and route between them. Protect traffic with access control lists and security groups. Make sure you've got security guards and strong physical security by the systems that connect to the cloud provider. Use incredibly strong passwords, template known good configurations with CloudFormation templates or Terraform templates or something. Backup. Create images of your production servers. Make sure you leverage auto scaling, which can scale up, because one of the things that can take you down if a server is too busy or a DDoS attack. Decouple your architecture components so that if little individual pieces go down, systems can stay up. Leverage caching, because your web server could be down, but some of the information could be cached, making it be there. Use highly redundant DNS in every different cloud provider, for example. Leverage load balancers to remove single points of failure. You're going to be constantly logging and auditing systems. You're going to be monitoring for systems alerts. You're going to monitor for security breaches. You'll monitor for performance. You're going to have to monitor everything. And you're also going to have to implement robust change controls, change management. Part of making any change which can impact the organization, you need to go and speak to all stakeholders, address stakeholder concerns, and find a time and a place where you can do the things with minimal damage. And there is about as much as I can do. Like I said, it takes me about 50 to 150 hours in our cloud architect career development program to teach people how to design high performance, high availability architectures, minimum. That's why we've got 700 hours of training in our architect program versus 12 hours of training in a certification. Let's briefly talk about the exam, and then we're going to shoot over to Zoom. So the AWS exams don't have a lot of content in them, but they ask questions in a manner that could be challenging. The questions are extremely wordy. If you have an experienced background, it's going to be harder than if you've never learned anything before, because if you know one answer may be the IBM way, one may be the Cisco way, one may be the Microsoft way, and one may be the Amazon way. So if you actually have knowledge and experience, these exams are going to be a lot harder. You're going to have to shut your brain off and try to pretend that you don't know anything about tech and this is your first exam. If you're new, and you've only learned this, it's going to be simple for you. So keep that in the back of your mind. Don't think too much on these. I want you to think about how they would word it. I recommend that you read this book and carefully look at all diagrams. I recommend that you go to the AWS website and read the white papers. I also recommend that you do some of the AWS skill builders to pass the exam. And I recommend you get this information from AWS, nobody else, AWS, because they make the test. I also recommend that you get a practice test. The way Amazon asks these questions is a little ridiculous. So get used to the way they ask the questions with the practice test. Last thing I'm going to say, the day before the exam, half of the exam challenge is reading these questions and understanding them. It's like they hired people with bad writing skills to write these questions intentionally to make them harder. So the night before the exam, don't go partying with your friends. Don't go out drinking. Don't have some Macallan 25 where you're going to wake up a little foggy in the morning. Get a good night's sleep. The next morning when you wake up, eat something healthy where you're going to feel good. Don't drink alcohol the night before. Don't take any substances that could impair your judgment or thinking or memory the night before. You want to have your brain there. On the exam, arrive early. Sometimes your computer crashes. Sometimes they put bad software on you. Make sure you've got your ID with you. Make sure there's not a line or a queue that you're waiting for. Kind of keep this in the back of your mind. Park in the parking lot at Spring for parking if you can. If you have to drive there, the point is you want to get there, you want to be calm, relaxed. Bring your photo ID and go in there, relax, don't panic, and just go with it, and you'll pass the exam. It's not a complicated exam. It's an issue of just understanding the questions. So I hope you guys had fun with our completely free AWS Solutions Architect Bootcamp. We're going to jump on Zoom and we're going to answer questions live. We can have some conversations. We can have some fun because we can have this. And I'll see you on Zoom. And as a reminder, in case you just joined, we have right now, you guys are all invited because you've attended this to early Black Friday access that we have, which is 40% off of every program that we have. My team will prop a link to that. And I highly recommend it because there's a big difference between certified and hired or hireable. Certification is about 5%. We still got to talk about the other 95%. And you can find that out on our completely free webinar on Monday, how to get your first cloud architect job, and the completely free how to get your first architecture job ebook that we wrote for you. All of them are there. So I'm going to take a 2-minute break and I'm going to see you all on Zoom. My team is popping all these links. Any of you that want to come to Zoom, party time, log into Zoom and we can talk face to face, ask your questions, and I look forward to meeting you all in person.